Dear offshore charging enthusiasts and everybody who's a big fan of maritime sustainability, welcome to the Project BOEI closeout. Over the past 6 months, we have performed a feasibility study for the Province of South-Holland and also InnovationQuarter, and we are situated here at the beautiful campus at sea. And for those of you who aren't sitting here and sitting at home, let me show you what you are missing. This is a view of, well, actually the beach, but it's really close by. You can see these vessels laying here. And this is a view of the anchorage at Scheveningen. And normally a maximum of about 10 vessels can moor here, but we've seen the data and they do tend to cheat a little bit. It's very crowded. It's not one of the most crowded places of the North Sea. And also sometimes more than 10 vessels are moored at one time. You can imagine that causes quite some emissions. So before we start with the presentation, anybody here take a guess? How much emissions are we talking about? I'm particularly interested in NOx, nitrogen. Well, some people already know what we're talking about. Studies were done in the past, stating that it was roughly 1% of, call it, the budget of South-Holland. But actually, new calculations that we provided show that it's 10-20%, maybe even more. So this actually is a very big single point source of emissions for the entire province of South-Holland. I'm going to show you how we calculated it. And during this presentation, we're going to do it together as well. And you can all join me in doing the calculations. So this is a big issue. And what we have done in the past 6 months together with these consortium members is to have a look in what it would cost and what the technical solutions would be in order to reduce these emissions, accelerate the maritime energy transitions, and in short, electrify tanker vessels that you see here. We have 3 parts for this presentation. The first part is the current situation. We'll have a bird's eye view of the anchorage itself. The second part will be the fun part. Well, actually, everything will be the fun part, of course. But the second part will also be interactive with your help. And then the third part will look into how we can actually make this happen starting next year. But next year is pretty close by. So, yes. So let's start with part 1, the current situation. Here we have an overview of the anchorage, and that purple area, which is now green with an anchor, that's the anchorage that we are talking about. So for those of you sitting here, it's actually right out there, right out the window. You can see the ships being moored there. And even with these high wind speeds, they're still moored there, which is also one of our questions that we had. But basically up to 10 ships can moor at one time. It's 6 kilometers off the coast, closest by, and it's also roughly 3.5 kilometers away from Q13, which is one of the most innovative Dutch platforms, offshore platforms alongside the Dutch coast, and it's also fully electrified. One of the other projects that's being done there is Poseidon, and we make hydrogen or going to make hydrogen offshore. And there's also an innovation lab close by, or an innovation hub that we're going to speak of. So this anchorage sees on average about 6 ships for the entirety of the year. This is data from last year. So this shows roughly, well, let's say November 23, it was least amount of vessels, but that was also when the data was still running. So let's say 6 to up to 25 different vessels each month. So there's a lot of vessels moored here. In total, top of my head, 244. 80% of all the vessels are tankers. And guess what? We actually took a reference vessel from one of the consortium members, Knutsen, the Toro Knutsen, and it's actually moored outside the window right now, looking at this presentation, seeing if we're doing everything right. So it's a bit of a coincidence, but these vessels on average are moored 10 times per visit, up to 70 days for tanker vessels. But if you look at the most amount of days moored for different ship types, it's actually cargo and 4 dredging vessels who are moored here up to 170 days at a time. We have to remember that 171 because we're going to use that for the business case later on. This shows us that there are a few vessels who stay here for a very long amount of time, and that's something we didn't know 2 weeks before. That's key. Okay, so that's the Anchorage itself. Then one of the biggest drivers for this project, and people living in the Netherlands know what nitrogen is. People outside also know what nitrogen is, I hope. It's a big part of our air, but NOx depositions are a big issue because in the Netherlands we emit too much NOx. So we've looked at 3 different scenarios. Actually, we did a lot more, but maybe I can show you later. But roughly 3 different scenarios of deposition on the closest nature reserve close by. It's called Meiendel. It's a beautiful reserve, by the way. We looked at a low scenario, the medium scenario, and the high scenario. So the low scenario would be 3 ships on average. Medium would be 3 ships, but a little bit more emissions. And the high scenario would be 6 ships. And as you can remember, the average that we are talking about now is already 6 ships. So we're already at high level. And what Gijs and I did, we looked at the emissions, and I can state with a fair amount of certainty and some assumptions, fair, that 800,000 kilograms per year is a minimum. I believe it can maybe even be twice as much, which means that at this moment, the high deposition, so the amount of NOx that actually lands on the beautiful nature reserve in Meiendel, is 7 mole per hectare per year, which is dubbed significant, already almost 10% of the budget of Zuid-Holland, and I can bet it's actually a lot more. But we need technical data from the vessels, and technical data from 200 vessels is quite tricky. So our proposal would be to actually measure in situ and of course at the Meiendel as well. But anyway, no matter how you calculate it, and we did it in many different ways, which can all be viewed online, it's a lot bigger problem than we thought originally. So that's of course what we're trying to solve. And considering this project is called Project BOEI, especially for the Dutch people, you probably know what's coming up. What can we do about this? A buoy. Exactly. We've had the pleasure of working together with Bluewater. They have made, or have this buoy already for over 40 years at some places in operation. Originally designed for FPSOs. They've refitted it and made it for power transfer. This is a offshore crew transfer or offshore support vessel that's usually moored close to wind farms. And we've actually looked at how we could use this for tankers. But this is just one scenario. Maybe we don't need a buoy, we need a monopile. Maybe you have different ship types. Maybe we don't use Q13, the offshore platform, but we're gonna take a cable from land. Basically, we have about 100 variables that can change a lot more ways than we can think of. So how do we tackle this problem? We have made our own model of this project, and now we're gonna take you through it so you can make your own scenario. And we've done this many times already. So usually when you do these things, something breaks. I hope it doesn't, but this tool and everything else that you will find during this presentation will also be online as of today. So we'll make sure that you get the link either way. Here we have a small tutorial. Well, I am the tutorial at the moment. We do ask you that you understand that this is only a model. Input in is input out, but if you don't have the correct input, well, you all know what that means. So we need to understand that we use certain assumptions. We have the project itself and different options. We have ship equipment that we need. Then we have CAPEX and OPEX. That's where it really gets interesting. And then finally, the business case. I've been doing maritime sustainability for a long time, and I can assure you, in the end, sustainability is also money. It needs to be economically sustainable. Otherwise, it's a nice feasibility study, but no one's going to do it. So first, the project. This is complex, quite technical, but we have 3 different scopes. The infrastructure required, the E-anchor, as we call it, the buoy, and the ship. And funnily enough, no matter how you divide different scenarios, we can have the scenario that we use Q13, for example, or we can have a scenario that we drag a cable from land. But no matter the scenario, the subcomponents of this project will remain the same. And that's how we build it up. You can choose different components that will certainly impact the costs, but technically the subcomponents will remain the same, because what do we need in the end? Power at the vessel. Basically, that's it. So I'm going to go back to scenario 1, because that together with another scenario, was our best case scenario for many reasons. And here we've looked at all the different infrastructure requirements. As you can see here, this is an example, and this is also an example of how risky things can and could be if we do such a thing. Because if we have 10 vessels moored here and 250-meter long tankers moored while other vessels are also moored, that's also a very risky operation. So we're going to show you later, this will probably or most likely not be desirable from a permitting and a safety standpoint. So we need to do something about the infrastructure itself. But we've looked at a few scenarios that could make it work. Of course, we have the E-anchor. We have two options for the E-anchor. We can use a monopile design or an E-buoy design, but for all intents and purposes, for the feasibility, that doesn't matter. In fact, costs are of course debatable. There is especially a difference in maintenance later on, but in terms of capex costs, they can be viewed the same. And here we have our favorite vessel, the Toro Knutsen, courtesy of Knutsen, which is moored outside. And here we have all the data that we've put it in order to especially determine the average power consumption. And for these vessels, that's roughly 1.5 megawatts. Okay. It's a lot of information, I know, but you don't have to ask questions at the moment. You can save it for later. What we've done now is we've stated, this is simply for modeling purposes, that the vessel is moored for 365 days a year, so we can compare how it would do. And of course, 38 days at Anchorage, we can shift it around. So 171 days was the max. I'm not going to do it now, I'm going to do it later. But here you can actually change, if you have a different vessel or different project parameters, the amount of days that the project is actually moored. And then you can get an estimate of, okay, 20% moored each year. Yeah, that could be close or not. You can change. Everything else is filled in. As you can see here, you can have a double check to see if your fuel and energy consumption is correct. OPEX and fuel parameters. All right, this would then roughly be the costs. You can change your fuel type here. You can change the fuel costs. You can change EU ETS cost. Then we're going to see what kind of shore power equipment we would need. There are a few customization options here as well, but as you can see, this is all, let's just say we've taken care of this specific scenario, and we can input a lot of different scenarios later. And I want to change the capex especially, so you can see how that impacts the vessel. And we've also looked at the general arrangement and single line diagrams for this specific vessel type. So part 1 and part 2, making sure that the project is correct. Now we're moving on to capex. Number that everybody is of course thinking out loud. How much is it going to cost? Right now we're thinking 12 million in terms of total capex for the infra and E-anchor part, subject to change, and roughly 2 million for the ship part. Here we see that we have included the E-anchor with the infrastructure part. You can also separate those different scopes, but we have considered only a single provider of energy. And then you get the question, okay, Vincent, I see that your second transformer down is 900,000 euros. That's really neat, very nicely rounded up. Is that actually correct? Well, I'm not sure. I can tell you that I'm pretty sure that it's not correct. It's a model, so it's never close. Well, it's never correct, but hopefully it's pretty close. And we can say it's close enough. What we can do is here, if we go to the ship and we see a breakdown, we can do show more. And if you say, okay, we did the onboard transformer. I see I have 0 now. Let's see if it works. If we do have a transformer, that's going to impact the cost here. Or I don't need a transformer. Well, I like Transformers, by the way, good movie. So let's say rental tools. I don't need rental tools. What would you like to have? Blank.
Double plugs.
Connectors and double plugs. Okay, connectors, double plugs. Plus, yeah, okay, so we need about 10 of those, and it's going to cost us 500 euros a piece. So it's fully customizable. So even this is more or less a pre-population of the data. We take good care of how we come up with the information, but you can always change it later. And that will, of course, in the end, impact your bottom line. Ooh, that's very expensive. So I'm going to remove the transformer. Yeah, because I'm pretty sure then the business case won't matter much. Well, we still have subsidies, so we can always make a business case, but still. So this is how we came up with the list of capex. OPEX as well, by the way. We have an estimation of the OPEX. Here it's simply a list, but in the business case, it's more important because that's where you actually make the money. So moving on to the final part, and now I'm going to zoom in because this is a smaller picture. What do we see here? We have the infra and the ship. I've put them together because both of these parties need to make money. What are they doing now? Losing money. Yeah, so this is not a particular good case. What we see here is an investment, 10 million. It's going to take well beyond 2031. And here we see the vessel is actually losing money because probably the electricity costs compared to the fuel costs are too high. So we're going to customize. First thing we can do is lower the price per kilowatt to make sure that the ship owner has at least some sort of payback. And I know for a fact that we need to be at about 20 cents per kilowatt hours. Then we have days at Anchorage. Remember the maximum amount of days that we had? How much was it? It's not a pop quiz. 170. Yeah. So this is, let's say, an optimum case. Average power, I'm going to leave that here, but that impacts the analysis also tremendously because that directly translates to the amount of kilowatt hours. So we have roughly 48% occupancy, but still not enough for the infra to make money. What can we do? Province of South-Holland, can we please have some money? Okay, he's smiling, so that's a maybe. What we of course can do is add some subsidies. So we could say, okay, in order to get a good business case means payback time, we need roughly 3 million subsidies. That could be one option. This could be an option in order for both the provider of power and the ship owner to continue. But we also need to, well, of course, this is a ship owner, and I can bet every ship owner will disagree with the fact that they're laying at Anchorage for half of the year for at least until 2030. That's also not feasible. But then again, we can also state that is it fair to put all the capex for this connection on this single project? Maybe not. So what we could do is we could state, okay, I'm going to show more. I'm only going to do, let's say, 50, 40, 35%, 30% of the price that I have to pay for this connection, I will attribute to this project. And here we see we're already getting a business case that might be viable. We get a provider who gets his energy or his payback with years. We only need a few million subsidies, and the ship owner is happy because in, let's say, 2 years, it gets his investment back. And then there's one thing that can make this entire business case, and that's renewable energy units. And we have them here. They're called renewable fuel or renewable energy units. In the Netherlands, there's an economic incentive in order to electrify vessels and ships. Normally, you get 5 cents per kilowatt hour if you use gray energy. Jan-Hendrik, I know that you're also working on providing floating solar. If we could add floating solar to the mix, we could have almost 20 cents per kilowatt hour added when the provider sells it to the ship owner, and then we get an extremely interesting business case. We might even not need subsidies at all, even though I would still be a proponent to reduce the risk. But here you see you can already make a viable business case with no subsidies. You do need some commercial agreements with perhaps even multiple ship owners. That's the key. Yeah. Economically okay. That's the message that we should remember. All right. And this, of course, will be brought online, and you can also play around with it yourself and see where the sensitivities will lie. Moving on to the final part. We're almost there, the way forward. This is all nice and dandy, but if we really want to make it happen, what do we need to do? We have made a proposal project planning guide because this is still feasibility phase. There's a lot of uncertainty revolving around it. We've identified 3 different phases, phase 1, 2, and 3, of which phase 3 we say, forget about it for now. That's too far ahead, too complicated with the current parameters. And we have phase 0, which is the design and commercial phase. So we start off with an engineering design and commercial phase. Then we have a single vessel phase, hopefully the tall Knutsen over there connected to a single buoy. Then with the numbers that I have shown, you can connect up to 3 vessels. So we've taken into account additional improvements or multiple vessels, so you don't have to pay too much for expansion later. What's going to happen afterwards? That's looking into a crystal ball. So I propose to look at these phases and not beyond. How does it look graphically? We have phase 0, 1, 2, and 3. Most important of phase 1 is making the business case that we just saw fixed, getting commercial agreements in place, and also doing a demo or a pilot. And Bluewater is already proposing a demo, or already planning a demo with their equipment. It's not necessarily entirely sure how that will look, but they are planning to do a pilot demonstration close to the offshore test site. Exactly. With that information, we should know more. We can maybe look at alternatives, but basically that's the whole goal of phase 0, narrowing down the commercial aspects and the engineering aspects. Phase 1 would be actually the completion of a single anchor. For those of you who are really paying attention, you can see that these numbers are actually slightly different than the ones we have presented. That's because a technical and commercial trade-off needs to be made, whether you're going to do the transforming and converting of the power at Q13 or at the Anchorage site. That's a trade-off because of many reasons. We can maybe discuss it later, but that's one of the biggest trade-offs that needs to be made. With that equipment, whether you transform the power at Q13 or offshore, you can at least power 3 different vessels, and maybe even more. But I've made this image to show you that if you really want to have 10 vessels like the Toro Knutsen 250 meters plus, you need such a wide berth for them to maneuver properly, and you don't want to have them sort of intermingling, so you want to have them maybe even stretched further. So you need a change in anchorage geometry at the very least. That's at least what we suspect. All right, this is not good enough. We need to have more steps. It needs to be clear. So we've also proposed a few different real actual steps that you could take starting next year, starting in 2 weeks. The ship refit plan, here it says 6 months, 5 months. We can probably do it in like 5 minutes, but we don't know which vessel. So we probably need some more time to figure that out. E-anchor design, big issue, gonna take time. Selectivity study, that means what if a breaker or something at the vessel happens? How does that impact Q13 and or the land connection here? We don't want to have a blackout of the platform in case somebody tries to do something weird on the vessel. So we want to do a short circuit or selectivity study. Then we have the subsea cabling design. Once everything else is figured out, then we know then we need to look into how to connect it physically on the ground. Of course, an installation method statement of that installation has to be made. The trade-off that we discussed needs to be made up front. That's one of the biggest trade-offs technically that we have to take. And then finally, in order to ensure safety offshore and the nautical operational aspects, we also want to do a simulation of how these 10 different vessels, if they are anchored, would work. So we need to do a simulation either at Marin or I come from Hirama, so no, they have a very good simulation center as well, in order to get a look and feel of what would happen in case of contingencies. Ending with a demo pilot, which is in May, June planned by Bluewater. Who knows, maybe we can join them or not, but at least some sort of real physical evidence needs to be made. On the commercial aspects, we have the availability of Q13 versus the business case, including kilowatt hours price afterwards. Subsidy application, if needed, that takes a lot of time. Permitting application, as we can see here, we might even need a year for that because there are some permits that take a year. And then obtain launching customers, which is, I think, the key in a commercial agreement at this point. Ending with, of course, an MOU between provider and the different ships. All right. You can take your breath now. That was the presentation. Everything we've learned in 6 months has now been crammed into, all right, slightly over 25 minutes. But in the end, we truly believe it is economically and technically feasible, and there are certainly big challenges to overcome. The biggest is most likely safety and operational aspects offshore. That's why we also say, forget about the 10, focus on the 1, start today and take it from there. Thank you. Thank you.
Okay.
Time for questions, guys. Maybe there are already some
we
questions.
do have some questions, yes.
Yeah.
Question asks how to protect / secure the submarine cable on the seabed.
Ah, yes. Trench it.
Trenching.
Yeah, all cables. I don't think there are many. All cables need to be trenched, at least 2 meters. So they're trenched all the way up to the e-buoy or monopile anchor, where you have some sort of umbilical end termination assembly or big plug, and then you connect the dynamic cable to the buoy or satellite. Yeah.
Okay.
And even then, you might want to add like rocks or dumping, or make sure that there's a lot of. I mean, on a day like this, you have dunes shifting around at the North Sea, especially at those water depths. So you probably need some additional protection and at least visual inspection yearly. Yeah. Yes, Edward.
Smooth presentation, loved it. I have some questions on the execution, but starting at the significance of the nitrogen, 10 to 20%, that's a lot. So yeah, maybe it's not your question to answer, maybe it's more the province, what is the significance, but because it's a lot, it's more than we initially expected. So what does that mean for either the urgency, the problem, the parties involved?
Money involved.
Yeah, yeah, of course.
Also the design, because the closer by you get to the shore, the more the more benefits it has. So now you have your first idea of in the the western part, but you should go to the near shore.
You're correct.
Corner.
That's true. Yeah.
But that's the technical part again.
True.
As
As
a novice, I would say the problem has gotten larger. But how does this work in reality? Because is it obviously it's realistic nitrogen, but is also nitrogen a problem on paper because it's offshore created? Is that a problem for current legislation on land? So how does this work?
My colleague Robert hasn't showed up, has he?
I don't believe so.
He's not online as well, is it?
No.
Because he is the nitrogen. No, it's not about the heat. Oh, yeah. My question was about this 20% because it's quite a difficult calculation. So it's you said of the supposed budget, but what do you mean exactly by that?
There's apparently a maximum of the amount of deposits for this nature reserve, and this would equate to 10-20% X% of that. So
it's
allow
7 moles per hectare.
Yes, and I might
instead
be
of 0.7, so it's 10 times more as you expected.
Yes, 0.88, but we are now at 7.07.
Yeah,
I know
3 vessels, half year around.
6 vessels, entire year. We know that's pretty close to reality. But we don't know the exact technical files of
it's not close to reality in terms of, because if you want to have this, you need to at least have 50 different ships.
Yeah.
Being retrofit to a plug.
So the longest duration
the total
stays.
cost would be more than this 12 million you proposed.
For the ship owners, absolutely. That's all divided, and that's what makes this problem so hard. All those ship owners have to incur costs, maybe 1-2 million for the bigger vessels.
Yeah, but they need to do it anyhow because of the Wallstroom discussion in the harbors.
So that's also the benefit. Yeah.
I think one main benefit is for the maybe you can check that is for the Port of Rotterdam, because they can determine whether they need a shore power supply or not.
What do you mean exactly?
The owner of the anchorage can determine what the specifications are to be for the ships at the anchorage. So they can deny anybody who doesn't adhere to their rule.
Yeah, absolutely.
So if they determine that there needs to be a shore power connection of 500 kW at X or X, then they're legally obliged to connect, and they can't use their auxiliary generators.
Well, I'm not sure if he's here in the audience, but one of the people missing is, of course, the boss of the anchorage. We spoke to him only 2 weeks ago. There's still some debates going on about what exactly needs to be done, because, of course, if it wouldn't have cost us anything, we probably want to do it, but still, there's a lot of rules and regulations surrounding these anchorages. They should be safe havens for these vessels. There's a lot of safety issues in general with these types of anchorages, etc. the Coast Guard, Rijkswaterstaat, the Harbour Master, they all have a say in this. So that takes some time. So you cannot simply, we especially, but in general, you cannot simply state, build something there, connect to it, especially not if you...
Yeah, so you should...
In the longer term, this will.
In the longer term, yes,
will-
of
will
course.
this be
You
the
should
case?
go find a launching customer with
Yes.
which you are
Yeah.
developing it.
Yeah.
For instance, the Rijksrederij.
And then you get maybe a question of, is that fair? Is that because then you sort of cut off space for different vessels of the anchorage? So that's also something that needs to be thought of. So there's also a lot of debates that need to be waged on that topic. But indeed, you need a launching or multiple launching customers. Yeah. At least something to get the ball rolling. Yeah.
Okay. Another question from Dick. Can you value the NOx in the model? I think it's translated to money.
You can always value it. It's not in the model at this moment. We knew that from previous subsidies for shore power, it was valued at approximately 300,000 euros per mole per hectare per year. But that was counting backwards. So there was subsidies for nitrogen reduction projects in which they gave away money. They gave a subsidy for a certain nitrogen reduction amount. And that equated to what I've been told, roughly 300,000 euros per mole, which would in this case equate to roughly the subsidy that you would need, which is a nice coincidence. But these subsidies are now closed, these calls. So that's at the moment not possible.
And it blikt only the harbor and not
Yes.
the sea.
It's not at sea, it's only in
But they
port.
are opening a new subsidy scheme coming time.
Yeah.
But I think that's not for nitrogen purposes. Although your findings are very relevant also for the
Yeah.
Walstroom discussion in harbors.
Yeah.
So anyhow, if you're correct with your calculations, or we should try to make it more by measuring.
Measuring, absolutely.
Then it's really a big discussion, and also a political one. In
Yeah.
our province, in
Yeah.
our regional government, that's the Farmers' Party is also in charge, and of course they want to find other scapegoats as the nitrogen emitters, and this is a big one, and a big one who can be abated.
Yeah.
In a reasonable time, so it is really relevant for that.
Yeah.
Of course, there are other solutions. We can just skip the anchorage point or shift it out
Doesn't
more,
cost you 12 million.
more far out at the sea. Then the problem solved as well.
Yeah.
You might say.
Yeah.
But of course, the whole development with the grid connection we are developing the coming year, it might be really relevant and interesting to hook on to this development.
Now, our mission is to make it green power. It's powered by floating solar and energy, wave energy.
And also we shouldn't overcomplicate things. Basically what we're building here is the world's first fastnet at sea.
Yeah.
It's roughly the same dimensions, power profile, etc.
Sure.
It's just at sea,
Sure.
and the ships are a bit bigger.
But we're not the first or the only ones, because it's Scotland
Absolutely.
and other places. They are
Absolutely.
also
I understand.
developing
The first fastnet,
fast.
so the first Dutch.
And the other question I was wondering about in your presentation or previous, you said discussion whether or not to connect Q13 with it, or
Yeah.
that you might, because if you see it's only 6 kilometers from the nearest point of the anchorage point
Yeah.
from the shore, so you might consider just throwing out a new grid connection from
Yeah.
the shore.
Exactly. So that is the biggest trade-off that needs to be made. Depending on how commercial discussions that are currently ongoing, of course, with the current owner of the platform and the future developments, you could also say make a new connection from land. Then you can bypass all the Q13. I would say not really commercial risks, but at least you have one partner extra. It's simply the cost of the cable, so you have 2 times the length. That's basically it.
Yeah, but
But
you
where
have
will
you
you-
have the better nitrogen reduction. because it's more near shore. Otherwise, you start with 9
Yeah.
kilometers from shore, and then you go only 6 kilometers.
Yeah, true. Yeah.
But where will you connect the on land side?
Where?
Where's the power grid on land side? Connected?
Oh, we haven't checked that. We know
That's
that
the problem.
for Q13, that's.
That's over there.
Yeah, exactly.
But towards Meindel, there's no power grid at all.
No, but
No.
you can use the same here, of course. I would say.
It's a project.
Yeah,
so
that's-
it's not a project.
That's congestion. Yeah.
Traction,
You cannot readily state that you can use the same connection. What we can state is that there are 6 MVA spare capacity, so 6 megavolt amps available at Q13,
Yeah.
which means that it should also be available here. Otherwise, we have a problem. So you could make arrangements.
It's 10. No.
Yeah,
Yeah.
yeah, exactly. And they have
In total,
they
yeah.
use 4. Roughly.
Exactly.
So,
Yeah.
but you might be able to add to that power by getting floating solar, wind,
Sure.
additional renewables. But that's all. Well, that's maybe a different feasibility study. Yeah.
Okay.
But maybe. I was just telling that to Anouk. If I had, let's say, 50 million, because you want to keep some money after you spend it, I'd say I'd maybe personally go for a new land cable, because even though that might take longer, at some respects you're not dependent on Q13. I'd especially consider that option if you want to go for 10 vessels more there, so the really long term. That would be maybe a better solution, but then again, if Q13 is not being decommissioned, because that's being planned for the end of this decade, that's also one of the reasons why I would make a new cable. But if it's not being decommissioned or somebody else buys Q13, that absolutely would be the preference. So stating it differently, you need a different owner who's committed for at least 15 years, or a land cable. I'd say from a commercial aspect, that would be the case.
I would fully agree. But the problem is how to connect to the land grid.
Yeah.
Over there is, to my knowledge, no connection. Over there maybe, but also the capacity is limited.
Yeah, going back.
City inwards.
Yeah.
But if we're looking at broader developments of the energy supply, then you see that small grids and local grids are getting more and more attention. So
Yeah.
wouldn't it make sense to try to design local grid based on a central hub being Q30
Yeah,
once its commercial oil life expires?
that's even better.
Because then you prevent of the quite complex thing that you're doing now, which is getting offshore wind energy to shore, transforming it,
Yeah, everything
bringing it
bypassed.
overland
Yeah.
through The Hague, bringing
Yeah.
it back up here, bringing it to Q13.
Yeah,
So you could build your own shore grid, especially I think in line with Campus at Sea and the development of multi-use energy parks. It might be a nice study to see what kind of power supplies you need to build Q13 into its own energy island.
that will really be cool.
Yeah, that's our
Yeah,
ambition, of course, to make it the third sea lab, apart from Proeftuin, Noordzee and OTS. We are in discussion with Neptune Energy, but the complication is there is a new owner.
Yeah, it's-
yeah.
We get in contact in March for the first time. But also Neptune Energy Board is in favor of not decommissioning it in 5 years' time.
Yeah.
Leave the platform and get another future for 20 years, as George said.
Yeah, basically all you need is some commitment for Q13 for, let's say, 15 years plus at least.
Yeah, we are looking for 20 years, so
20, yeah.
because that's the same lifetime as we're planning the cable.
Yeah,
So,
yeah, makes sense.
makes sense, yeah.
Yeah,
But in the next year, I hope that we come to an agreement with Rini.
Yeah.
What would be the minimum and maximum power output of a buoy for ships?
minimum 0. Nah,
Oh, well,
that's-
it depends on the plugs, right?
Yeah, we know the maximum of the buoy that's in the report. I should ask Govert, but the maximum they stated would be roughly 5 to 6 megavolt amps per buoy, 11 kilovolts, and 500 amps, but I'm not sure, but you can calculate back. So the maximum will be, let's say, 5 megawatts roughly, which should be more than enough for at least vessels that are moored here. And then you can always custom engineer larger types of connectors.
Yeah.
I mean, the cruise connectors can go up to 16 MVA generally, or higher, up to 20, but that's not needed here.
No.
And the minimum, it's a good question, but the minimum depends on the ship types that you have, but at least you're looking at skeleton crew, smaller vessel types, you still need 40 to 100 kilowatt easily, probably more. For larger tanker, you need at least 800 kilowatts, at least these types of tankers. Yeah.
Okay. Yeah, that's the questions for now from the chat.
That's it? Okay.
One more question on the execution. So you have like nice next steps technically, commercially. Knowing you also identify probably who's in the lead for which work package. So yeah, who's going to be the next step? And I was particularly in the business case, like who is the right party to take the lead in developing it further?
Well, that's something I want to discuss with you by the end of January.
Okay.
First, looking at myself, because that's always how it starts, I would say we would be situated in conceptualizing, designing, maybe commercializing, talking to partners, etc. But you would need a larger, more dedicated engineering design house. Of course, going back to those that I know, Harema Engineering Solutions could do some of the engineering design. I know a former person at Steelstrom. There's somebody sitting at the table from Direct Cables who can do parts of it. So there are multiple engineering houses who could do sort of part of that design, at least. That's detailed and commercial. And then you need some sort of, organizer, project manager. We could do it. I'm not sure if we could do it. Depending on the parties that you have for the rest, would be best suited. But it also depends on who's gonna, of course, pay for the development. What's in it for them? Is it going to be focused on nitrogen deposition, province, etc.? Are we going to speak with the new owner of the Q13, because they have a lot to gain in terms of they're the ones who are getting the money in the end. So I think those two need to be considered first. There is momentum now. We have, and that's in the report, also a organizational proposal of all the different roles, plus not companies who could do it, but at least you get a blueprint of how it would work moving forward.
Is there an idea from the province how you would prefer the ownership of a platform like this to be? Because as the Anchorage is ownership of the Port of Rotterdam, if I'm not mistaken, it's quite hard to depict ownership of offshore assets. So would it make sense to have the owner of the offshore asset be the one in charge, or would you like to have this being done from a Rijk or the province?
For us, it's really difficult to say. I don't even know who the owner is of the Anchorage. That is a combination. So it is, and we don't have anything to do with it as a province. The only thing we are interested in is one hand is the energy innovation. That's why it started, and the second is now is the nitrogen. Yeah, we all are also depending on the money which is provided by the national government, and we are just a give through. And
the give through edge.
Yeah, whatever. No, for us we do this stimulant, and now of course we have to check with the Port of Rotterdam, and especially I think with the national government, with Rijkswaterstaat and other players in this field, what they might find relevant in this case.
Yeah. Answer Vivian stated that Rijkswaterstaat is owner of the anchor plant.
Yeah, that's what I thought. Yeah, but then still, if there would be placed an asset, whether or not floating or in a monopile, it makes so much more. New situations which nobody has dealt with before.
Yeah.
So
Right. Yeah, no, absolutely.
yeah, so now we first have to bring further the findings to the politics of the regional government, of the Port of Rotterdam, of the Port of Scheveningen. You had contact with them only 2 weeks ago, I heard. So for them, it's business as usual. It's the preferable side because they don't need to do anything. But if they need to do something, and they need, of course, we all agreed again in Dubai last week. So we should do something about this whole situation. It's of course difficult to find the first mover.
Yeah.
And in fact, we are the first mover because we are going to place coming year a cable connection in this area. So that's why this phase 0 would be very relevant. So whether or not this test is this grid connected or not, I presume not. But still, in the design, together with Rijkswaterstaat, because they also, that was still above the market, they also still want to have an extension of the anchorage. So and there was a small anchorage here, just here out. We discussed this also. Perhaps there are some ideas. So I think there is more to do with than what we have brought up at this moment. I think there needs to be more investigation and bringing together parties. I think we're just getting started.
And I would like to advise not to find one first mover or one owner of the assets, but make a coalition of the willing and try to find at least 4 or 5 parties, public and private, work together and join forces.
I have a brain fart now that you mentioned it. We can maybe discuss it after the recording stopped.
Think out of the box, and so perhaps Fastnet would be interested to invest.
Absolutely.
Party like that, the new next level in supercharging of super vessels.
You get Tesla on board.
Yeah.
I envision the new commercial of Fastnet. Also for your yachts.
All right, I think we're gonna wrap up. Thanks for your attention, also to those at home. The recording will be made available, as well as the tool and the report itself. And of course, a special thanks to InnovationQuarter and especially Province for making this happen. Thank you.
Thanks a lot.
Yeah, you can stop the recording and then we can bring out champagne.
Applaus vanuit de chat.
Oké.